So we're going to write the object output stream and object input stream program to prove that we can actually write the object circle with instantiate object of circle. For the default constructor, circle is serializable and has 1 as the radius, and for the arguments constructor we put pass 10. So this object created and write to the file's name circle.dat, which is generated here. And you see we cannot read that circle.dat because it is the binary files here that writing the object of circle in with owns radius. And we prove to read it back by read object. Of course, you have to make sure you throw while exception in case the file object is not found, file is not found, and then class not found exception in case we read back the object and we cannot find the class, which is circle. Casting back. When it returns as object, that's why we have to cast back as a circle. Then we can just get the contents back. So you may see the benefit of this object input and output stream is over the text file is if you are not necessary to read or create a report, you like file, then you could write a whole object, store it as a binary files and read it back. You don't have to iterate to get all the attributes values into the text file. It's going to be faster in the term of program efficiency running, because you don't have to spend time to decode and encode back into the text, and your code is short and easy too. You don't have to iterate to get all the values of each attributes and print as the text files for human to read. But if you need to create a report files for human to read, then you have to do the text file, like example text editors program. Now let's see transient, right? So if I put transient in front of this, and let's rerun the program. So it should ignore the attributes. If I don't, like by default, you don't have to put transient because statics it will taken care. It is non-serializable. Now, if I do, like if I have another class create inside as an attribute of this, so let's say a class is not serializable. So if I want to say private a equals to new a. Alright, so let's see if we can still running that. You see that we get a exception, not serializable, because a class is not implements the serializable. So in this case, like we said, we still want to write a circle, then we have to do transient, right? So that's the point of the keyword transient here. We mark it as non-serializable object. Just like static is already marked as non-serializable object. Let's still be able to read and write like that. Okay? So that's the point of the transient keyword. So we see an example. Also, the arrays, an array is serializable too if all its elements are serializable. So if you have an array of objects, all the objects has to be serializable from the class that they created. Those classes has to be serializable. So an entire array can be saved using write object into a file and later restored using read object. Okay, you can look at the next example here. Right, so create an array of numbers and strings, and you can just write the whole thing as an object, numbers and strings, and you pretty much just can read them back. You write into arrays.dat, store them and read them back, cast them back as an array of int. When we cast back, we have to cast as an array, and this is a string, array of string, casting back, and then we should be able to run the program and see the contents back. Access files. You see this on the test. All the streams you have used so far are known as read-only or write-only streams. Alright, so we have read and write, read UTF, write UTF, read object, read double, read string, write string, and so on. Read primitive data type, read object types. Now what we're going to do, we're going to look at the external files of the stream are sequentially files, right? That cannot be updated without creating a new file. It's often necessary to modify files or to insert new record into the files. Java provides the random access files class to allow a file to be read, form, and write to a random locations. So we talk about we want to modify the file. How will you do that? We're not reading and writing, but we want to edit the files into the particular location. So Java allows you to do that. Otherwise, you have to always create new files all the time. But this one allows you to modify the file by using random access file. So you can say this is the file that I want to access. Random access file is just you want to access, you can close, you can get the file pointer, you can get the length of the file, you can read the file, you can seek the location where you want to change, make modification to the file. You can set the length, you can skip, and you can write to the location of the file that you change. Update the file. So now let's look at the principle of a random access file, right? It consists of the sequence of bytes. And there's a special marker called file pointer that is positioned at one of these bytes. A read or write operation takes place at the location of the file pointer. When a file is opened, right, the file pointer is set at the beginning of the file. When you read or write data to the file pointer moves forward to the next data. Let's stay there. So that means if you keep reading, it's going to read after that location. If you keep writing, it's going to write into that location, which is it's going to overwrite the data at that point. So random access files methods we just seen, right? We have read int, read long, write double, read, right? Many methods in random access files are the same as the data input stream, their output stream. You can see that. Now we have the methods like seek, set the offset from the beginning of the random access file stream to where the next read or write occurs. So we pretty much just move the file pointer by passing the position. This is long because it could be long numbers of integers, the location of the files, because the file size can be bigger than 32 bits, like size of the positions. Integer is not enough, it is long, as 64 bits. But pretty much just provide a number of location, number of bytes, right? Get file pointer returns the current offset, so you know where it is now when you get file pointer, where the file pointer is. Random access file, we have length method. return the length of the file. Write char, you can write the characters to the file as a 2 byte Unicode. So char is 2 bytes Unicode with high byte written first. Write char's string. So write a string to the file as a sequence of the characters. This is the constructor of random access file. You can provide the arguments. The second one to say RW stands for allows to read and write, or just only allow to read. So let's look at an example. So let's focus on this. We have the data in out.dat, which is wrote into the .dat file here. Because this is a file that we want to pretty much just read and write to. You can see that those other input stream, object input stream, data input stream, data output stream, file input stream, file input stream, file output stream, you cannot read and write from. You can read the whole thing, but you cannot write. Like, you can write something, but you cannot edit in the location that you want, like in the middle of the file, right? You can append to the end. You cannot make insert into the middle. But when you do use random access file, this you can do that. Let's say we want to do set length to 0. So this is an empty file first. We're going to write the data to files to test randomly write. I mean not randomly, sequentially loop 0 to 200. So we can write number 0 to 199 to the file. So we want to see what's the size of the file. So we do in out.length. So let's see the output. In out.length is going to say current file length is 800. You may see that in the test. Like, you have to answer what is output. It could be 800. Why? Because we write an int 8 bits, right? Is it 8 bits? So first you have to see what's the length returns. Is it returned in a bit or in the bytes? So by reading the methods, length returns long, the number of bytes in the file. So that means we have 800 bytes. We actually write 200. And integers, one integer requires 4 bytes. So 200 integers, that's why we times 4. We have 800 bytes. Right? Why integer 4 bytes? Because 1 byte has what? 8 bits. And 4 times 8 is 32 bits. And primitive data type in Java, int is 32 bits. That all makes sense, right? So that's why we have 800 length, which is returns bytes. That's why. It's not like string.size array.length. We cannot look at that way because this is the file and return the bytes back. Bytes count 800. Now look at the next one is we said we can move the file pointer to location 0. That's going to go in out.readInt. So when we read in, we get the first number we write to, which is 0. When we do seek, now seek always jump into the byte. If I do 1, it's only 1 byte. But this is an int. The next integer, which is number 1, should jump 4 bytes. So we move that file pointer 4 bytes ahead. And then we read in again. So that's why we get 1 back. So the same, we want to move to get number 9. So we have to jump 9 times 4 and read 9.